Why are convergence criteria important for training effective RL agents? Imagine trying to teach a robot to navigate a maze. You want it to learn the best path without endlessly wandering. That's where convergence criteria come into play. They tell us when the robot has learned enough to make reliable decisions. In reinforcement learning, an agent learns by interacting with its environment and getting feedback. The goal is for the agent to develop a strategy or policy that maximizes rewards over time. But how do we know when it has truly learned this? That's what convergence criteria help us determine. They set specific rules to decide when the agent's learning process has stabilized and further training isn't making a big difference. Without these rules, training can either stop too early, leaving the agent undertrained, or go on forever, wasting time and resources. Convergence criteria are like a checkpoint in a game. They ensure the agent's behavior becomes consistent, so it performs well without unpredictable changes. This is especially important because if the agent keeps changing its policy, it might settle into a suboptimal way of acting. Proper criteria help us spot when the agent has found a good enough solution and can stick with it. They also prevent us from wasting computational power on unnecessary training. Training reinforcement learning agents can be costly, especially when using complex environments or large data sets. Knowing when to stop saves money and time. These criteria are based on mathematical ideas that make the training process predictable. For example, they look at how much the agent's performance metrics, like total rewards or value estimates, improve over time. If these metrics stop changing significantly, it's a sign the agent has converged. Techniques like smoothing the learning curve or early stopping are used to detect this point. In real-world applications, such as AI tools like ChatGPT or image generators like DALL-E and Midjourney, stable models are essential. They relying on the idea that once training is complete, the AI will behave reliably and ethically. In the end, convergence criteria are vital because they mark the moment when the reinforcement learning agent has learned a stable policy. This ensures the agent performs consistently, uses resources wisely, and aligns with the theoretical foundations of machine learning. Without them, training could be inefficient or ineffective, making it harder to develop reliable AI systems.